Another thing you'll see with a lot of these newer beach homes, and ours in particular, is basically over the last few years, because of various code changes, beach homes in particular have had to meet certain engineering criteria to withstand winds and storms. So what you have here, if you look down here, this X-bracing, all this X-bracing with heavy bolts and all the columns going up with the bolting, all that has to be engineered so the house can withstand storms from any direction. That's a big change over homes built even 5 years ago. The codes have strengthened quite a bit on homes. And so what you're getting with a new home today is a much stronger home based on that engineering. And a typical example is we now have to calculate upforce engineering loads. Up until a few years ago, there weren't upload force considerations in our code book. So now we have upforce loads, so that basically if you watched any of the storm clip footage of some of the storms in the past, you'll see sections of the home blowing away. Well, they didn't account for the up forces. So homes today have to account for those up forces, and that is lift. Usually you consider load, but now we have to do lift also. And when I say engineered for up forces and engineered for load forces, in this case we're talking from foundation to all the way to the roof. The whole structure has to be tied together in such a way that it can handle lift from the foundation all the way to the roof and all the way back down. So it's a full system that we're talking about. So if you look at the way the plywood is done, if you look at the way everything's done according to an engineering plan. The plywood has to overlap each floor so that the floor system is actually tied to each floor system. And they have to be alternated. If you look at the pattern of the plywood, for instance. Everything is, all the parts to the puzzle, and there are different ways of doing it, but all the parts of the puzzle have to work together and be engineered together. To go on with the structure and the engineering of it, just an example of how things are plated up here at the roof level. If you look at the plates, the number of plates and the type nailing patterns on each of these plates, everything has to be engineered so that we've got the up forces and loading forces accounted for. And if we look over at the beams that have come up from the ground level, you can see that they're bolted into structure. And so everything from the ground level up to the top has been connected and bolted. As we were talking about the engineering of a home and how things are engineered, and we talked about how the roof is tied into the foundation, here's another example. Here we have a freestanding wall next to the stairs, and in order to pass the engineering, we have to strap the inside of this wall in addition to sheathe the outside so that it again ties that roof down to the foundation. And you can see by these straps how the nails are spaced every 2 inches, and they're double nailed. What we're talking about. Each one of these nails has a shear force of 1,100 pounds. So you start to add up the shear force ability of this in terms of an uplift. You've got a lot of pounds just in each one of these straps. Just another example of how to keep the house engineered from the foundation to the roof.